For our physics extra credit project, we are going to be finding the coefficient of kinetic friction between Ellie's clothes and the surface of a slide as she slides down. Using the theory of conservation of energy along with forces, we will utilize potential energy along with kinetic energy to determine the coefficient of kinetic friction. Because we do not live in an ideal world, we need to account for non-conservative forces, thus allowing us to find the energy that is lost due to friction. By finding the force of friction using energy concepts, we are then able to solve for the coefficient of kinetic friction between Ellie's clothes and the slide. Because the coefficient of kinetic friction between leather and metal is 0.4, we can predict that the coefficient of friction between Ellie's jacket and the plastic slide will be lower than 0.4 because her jacket is more slippery than leather.
Okay. All right, go. Are you ready?
Yeah, go.
Workout I've had in a long time. Okay, you ready?
Yep.
Okay. There's so many splinters. To find the measurements of the slide, we measured the horizontal, which is A in this picture, the vertical, which is B, and later on I'll be using the Pythagorean theorem to find the hypotenuse, which is C, the length of the slide. Unfortunately, I was not able to get a video or even a picture of me making these measurements because I went to the park with my sister at 5 p.m. and it was dark out and my phone died, but I promised Mr. Howard I made the measurements myself. As I said earlier, we found length A and length B of the slide. We found that A was 2.1175 meters and B was 1.145 meters. To find C, we'll use the Pythagorean theorem, which is A squared plus B squared equals C squared. 2.1175 squared plus the 1.145 squared, which will equal the C squared. And we found that the C equals 2.41 meters. Now we have all lengths of the slide. We now have to find the angle of the slide. So once again, we know that A is the 2.1175 and B is the 1.145. To find the angle of the slide, we will use tangent, which equals B over A. Theta then equals the inverse tangent of 1.145 divided by the 2.1175. And we find that our angle equals 28.4 degrees. We timed 3 different trials, and to find velocity, you use distance divided by time. So for trial 1, we use the 2.41, which is the length of the slide, divided by 1.97. We got a velocity of 1.222 meters per second. For our second trial, we did the length of the slide, 2.41 meters, divided by the 2.04 seconds, and we got a velocity of 1.18 meters per second. And finally, for trial 3, we took the length of the slide, 2.41 meters, and we divided it by the time, which was 2.14 seconds. Got a velocity of 1.12 meters per second. Now, to find the average final velocity of the person sliding on the slide, we took all of the velocities, added them together, divided by 3. We got an average final velocity of 1.176 meters per second. To find the force of kinetic friction, we'll be using energy concepts. We'll be using the equation work of non-conservative forces equals energy final minus energy initial. Our energy final is kinetic energy. Our initial energy is all potential. Our final equation will be force of kinetic friction times the distance, which is the length of the slide, times cosine theta, equals 1/2 mv squared, mass times final velocity squared, minus mass times a constant g times the height of the slide. So we take force kinetic times 2.41 times the cosine of 180, since kinetic friction is opposing motion, which equals the 1/2, 56.7 kilograms, times the final velocity squared, minus the mass times g times y, the height of the slide, which then gives us a force of kinetic friction, which equals 250.16 newtons. Now that we have force kinetic, in order to find the coefficient of kinetic friction, we have to find force normal. If we look at this diagram, we see that force normal will equal the y component of the force of gravity. To find that, we first find the force of gravity, which is mass, times the acceleration due to gravity, which equals 555.66 newtons. We know that force normal equals the y component of gravity. To find this, we do the force of gravity times the cosine of the angle 28.4. We find that the normal force is 488.779 newtons. Now that we have force kinetic and force normal, we can find the coefficient of kinetic friction. We take the force of kinetic friction, which is 250.16, which equals the force normal times mu k. We find that our mu k equals 0.51. So our final answer was 0.51, which was a little off from our prediction of 0.3 for the coefficient of kinetic friction.
So in our project, we had a couple sources of error. Firstly, we did not account for air resistance. And then also for the sake of our calculations, we assumed that the slide was perfectly linear, but in reality, the slide was curved and the angle constantly changed as Ellie slid down. And we also made a couple human errors with inexact calculations.